Akilur Rahman. He is presently positioned as CTO of Hitachi Energy India, leading technology, digitalization, and innovation in the market. He has more than 32 years of experience in research and R&D, technology management, engineering, business and product development in power and automation technologies. Presently, he is leading the core automation and digital technologies for power, energy, and asset performance management in utilities, industries, infrastructure, and transport sector. Today, Mr. Rahman will talk about integrating sustainable technologies for smart electrification. So, delegates, let's welcome Mr. Rahman.
I would start with, as Ms. Akanksha talked about our country, we have declared the target for carbon neutral, that is 2070. And we know that many of the industries, many other countries, they have announced 2050 and also interim targets, many of the industries, utilities they have announced in India, like 2050, 2035, 2030 interim target to achieve carbon neutrality or moving towards carbon neutrality. And we as Hitachi Energy, we have also announced globally as well as locally 2030 target for us. And recent announcement by the government that by 2030 we are going to have 500 gigawatts of renewable energy, which is a very big announcement, very important one, and I'm sure we can achieve that. Although people think that okay, it's a long-term target, 2050, 2070, 2030. Still, it is long. So, but I think the actions we have already started as a country, as utility, as industry, we have already started that. So, and we have to move towards it very objectively. Just looking at 2050 scenario, see that by 2050 there will be of course, we know that the acceleration is shifting towards the renewable, but also there will be a lot of electrification happening in addition to transportation, what we are seeing today as electric vehicle, electric mobility. So a lot of processes in industry, buildings, there will be more of electrification where we are using non-electrical energy today. And electricity is going to be the carrier of the energy, not only just the conventional power energy, but also different forms of energy it will be carrying. So what's important here is to address these issues in terms of challenges. Also, we are going to have higher power system capacity. We need for more demand of power. Grid is going to be more complex and but there are technologies available, technology in terms of sustainability, having the sustainable energy, also sustainable products and solutions, and digitalization, which is going to play a role to make the grid for the smart city scalable, reliable, and resilient. How the power system is going to look like in future, which is of course including the city, because city they are going to be more and more power intensive consumer and also producer of power. So whether it is city or individual consumers, we are going to be prosumer in the sense producing energy as well as consuming energy. And so the picture here is not to getting into details of complexities, but you can see there are different technologies coming up, whether it is the new forms of renewable energy. Wind is already there. Solar is coming up more and more. Pumped hydro system is coming into the system, but energy storage, battery energy storage, hydrogen power, they are getting into the system. And also we have microgrid. Whether it is industrial establishment or residential or remote areas, so microgrid and with energy storage is going to be there. And on the other hand, on the load side also we'll have loads like electric vehicle charging, fast charging, ultra fast charging, flash charging, which is going to put different type of demand on the grid. To control this power in the grid smartly, we need different type of technologies, not just the conventional one, because we want the resiliency of the system. So resiliency of power system in terms of whether there is a dynamic change of demand or load and generation, but also looking at the disasters, emergencies, whether it's weather-related, natural disasters, tsunamis, earthquake. We have to make the power system more resilient because that's the backbone of our society and also the industries. And so not getting into the details, the system, the power system of smart cities, they have to be resilient, flexible, and also connectivity, connecting different type of assets, different type of energy, different type of ecosystem in the process. And of course, digitalization is going to also help in this. But at the end of the day, the availability of power, reliability of power, and also the economics of power needs to be addressed, and that has to be addressed in a dynamic way. That's the reason why we need more of automation, more of digitalization, and also making it real time control, protection, and also moving towards autonomous protection, so that renewable energy can be produced, stored, and consumed efficiently. So three areas which will give us the sustainability in the smart cities, sustainable and energy efficient products and systems, which many of the OEMs, we also have Schneider, a colleague from Schneider. So the equipment, the devices, the products and solutions we are making more and more sustainable using the sustainable material, and also addressing the sustainability of these products in the life cycle. Power electronics based control, because the conventional rotating machine is going to be less and less, and more of solar power. So how do we achieve the momentum in the system, the resiliency is in the system in a real-time basis, so that there the power electronics will help in terms of HVDC, FACTS, flexible AC transmission, and different type of power electronic-based solutions, which also includes the power electronic-based loads. For example, whether you talk about electric vehicle charging or green hydrogen production, electrolyzer, things like that. And digitalization, as we know that power sector has been into digitalization for several decades, but for the power, the control, protection. But today we are also adapting them for the asset performance management, in different time scales, starting from millisecond to second to minutes and hours, just to ensure that the system is more resilient and also predictable. And these are different elements of smart city, where we are going to see, as I talked about, different type of loads: EV charging, electric vehicle charging, storage of electricity, the battery energy storage, the hydrogen power storage, fuel cell based storage, as well as, on the other hand, getting the energy from the source, which are distributed. So not just from the remote, but also within the city, maybe outskirts of the city. So this needs the advanced distribution management system, the distributed energy resource management system, and also having all these things connected digitally with the digital substations, with the communication technology, 5G, in addition to our conventional communication which we use in our power domain. So this is one example of how distributed energy resource management we can have, right from the source, the storage, to control, SCADA, EMS, monitoring, and application. So this is going to be also part of the smart city, because within the city, as I said, it's not only the consumption, but there will be also production, there will be also consumption, as well as production by both by the same entities, whether it's industrial, residential, or individual. Rooftop solar, as this is a technology, but very important here is that it's not just about producing energy, solar energy, but how do you integrate that with the grid, in the system, in the distribution system inside the city, whether it's a residential complex or industrial complex within the city, or outside, outskirt of the city. So how do you manage this along with the grid dynamics? So very important, which is in milliseconds. So you have to run a lot of application in terms of forecasting, application in terms of control, protection, autonomous protection, so that the grid doesn't get into the tripping or blackout mode if there are some disturbances. The electric vehicle infrastructure, charging infrastructure, which is also very important for our e-mobility. This is one example of flash charging of bus, which, as Hitachi Energy, we have this technology. So 20-second it charges the top of charging of the electric bus. You can see here on the top, which is the sort of robotic arm which gets connected for 20-second when the passengers get out of the bus, so it gets charged. But you can just imagine, for 20-second it will draw a huge amount of power. Similarly, the fast charging, ultra fast charging, they will dynamically draw a huge amount of power. So grid should be stable. So the entire grid operation, the protection and control has to be coordinated automatically with automation, as well as with the AI ML applications, which will predict this for the future. Green hydrogen. So we know that hydrogen, which can be produced by the green energy, the solar, the renewable energy. So we produce hydrogen And the same hydrogen can be used, the green, which is called green hydrogen, can be used for the vehicles, fuel cell driven vehicles. It can be also used for storage of energy, fuel cell based storage of energy. So the entire cycle of power to green hydrogen and green hydrogen to power. So that is something is going to come in the city also, to have storage and also use of green energy. While we do all this, assets are very important. Assets of the power, the distribution system, the power evacuation system, as well as power delivery system, whether they are substations, transformers, switchgear. So we need to also monitor them, have predictability in terms of their health, because we don't want any surprise, any major equipment failing. We have seen that that leads to tripping of circuit, that leads to blackout of the system, blackout of some areas of the city, or it can also spread to the entire city. We have seen that. So that's why it's very important to, in addition to have the protection and control automation system, which has been there for several decades in terms of SCADA, energy management system, network control, but we also parallelly do this asset monitoring, predictive, monitoring of the assets, and provide prescriptive maintenance so that we can improve the uptime of the asset. And communication network is very important in the city, and there will be a lot of different type of devices in addition to the power network, where it is very critical. And we know that 5G also is coming in future, which will help the utility, the power network, the device communication better, more efficient. So we have, as Hitachi Energy, we have solution, the meshed wireless network, which can connect with the 5G as a gateway, and then the entire system can be developed, which can provide availability of communication to the extent of 99.99%, because that's what is needed for power systems. And finally, when we have this power system with all the digital, the sensors, the models, we need to do it on a sustainable way throughout the life cycle of the smart city infrastructure, smart city in energy and power system infrastructure. So plan, build, operate, maintain. So the same model, the digital twin, as Hitachi Energy, we have also come up with the Identic, which is the digital twin of a power installation. So this behaves like a physical equipment as well as system, and by which we can make the system more efficient in terms of integrating with the asset performance management, integrating with the new design which is required for the city, with the less of footprint, with compact switchgear, compact substations. So this is what we are going to do. And finally, it's all about, as I said, OT, the operational technology and automation for power system. Power grid has been there for several decades, but today we are having the sensors, additional sensors, having the data available in the cloud, sometimes public cloud, sometimes private cloud, on premise. But very important is that we can use all these digital technologies, whether it is AI, ML, AR, VR. So there are examples in each areas. And digital twin I talked about, and then use of 5G and also the blockchain. So these technologies we are using basically to achieve the performance of the asset as well as the system in terms of productivity, reliability, energy efficiency, safety, security. And cyber security is very important, because more and more system we are going to have with the automation and digitalization, we'll also have some risk of cyber security. So how we can design the smart city, the energy ecosystem, with like a defense in depth kind of approach, that we protect the system even if there are some incidents, accidents, or even intrusion in terms of hacking, the system getting affected. So how do we isolate it faster and also make the system still running without having large impact of this system, whether functionally from power system point of view, or whether it is cyber security and safety point of view. And so this basically the technologies are there in terms of the products, the devices, the sustainable products, devices, and also automation with sensors, with application of digital technologies to make it secure, safe, as well as resilient. So with this, I would stop here. So I understand the questions can be later or now.